Hello again. In this lesson, we're going to be talking about systems of equations by the substitution method. So let's begin. So we see a system of equation, which we know is two or more equations solved together. And so here is our first example. So let's follow a series of steps on how we're going to solve this. The substitution method, unlike the graphing method, we're not going to actually see on a coordinate plane where the two lines intersect. We're going to do this completely by algebra. So the first step is to solve one equation for one variable. Now, if we look at the examples over here, that's done for us already. And what do we mean by that? We mean that in this case, y has been isolated in both equations. So we're already ahead of the game. So we have step one done. We have a variable isolated. Step two is to substitute or plug in the expression you found into the other equation. So what does this mean? So I always think of this just like that scene in Indiana Jones and the Raiders of the Lost Ark where he's trying to swap a bag of sand for this sacred artifact on a pedestal. He's got to get the weight exactly right. We can make a substitution, but we got to make it exactly right. So I'm going to rewrite our first equation here. Y equals 3x minus 19. All right, I want to replace this y. I got to find something that's going to fit just perfectly in y's place. It's got to be the same amount of weight. All right, right here, this, negative 2x plus 16, it is equal to y. It says so right there. So I'm going to make this swap. So negative 2x plus 16, that must be equal to 3x minus 19. Unlike Indy, we got the weight exactly right. We made a perfect substitution. So we're going to now solve for the remaining variable. What do you mean remaining variable? Well, notice we had at the beginning two equations and we had two variables, x and y. Well, now we have one equation here and we just have one variable, just x left in there. All right, so we've done this. It's been maybe a little while since we've solved, multi-step equations like this, but we're going to go ahead and solve it like we know how to. So we're going to add 2x to both sides. We get 16 equals 5x minus 19. We'll add 19 to both sides. I'm clearly aware I didn't give you quite enough room here. And we have 35 equals 5x. Almost there. Divide both sides by 5. And we get 7 equals x. Great. Don't get too excited yet, though. Even though we have x here, we still need to find the other coordinate of our solution, of our point of intersection. So to do that, here comes step 4. We're going to use the value of the first variable to find the value of the other variable and check your answer. So if we know x is 7, what we're going to do is we're going to go back up into one of our equations and we're going to put in 7 for x. So y equals 3 times 7 minus 19. Well, 3 times 7 is 21. 21 minus 19 is 2. So our answer is x first, 7, comma 2. Make sure you are writing it as an ordered pair. Maybe that's secret step 5 here. Ordered pair. Oh, step 5. Ordered pair. Now, another thing is it says check your answer. You can know for certain if you've got the correct answer. Let's take that value 7 that we found and let's plug it into our second equation. So here we get y equals negative 2 times 7 plus 16. Well, negative 2 times 7 is negative 14 plus 16 is 2. Oh, good. We got the same answer. Well, better than good. That confirms it. 7 is the only value for x that would get the same value for y in both equations. That's what's significant about it. If we plugged in any other number for x into those two equations, we would get different y values. So if you plug it in and you get a different y value, backtrack. There's somewhere an error in your process. Okay, now let's go ahead and actually just try some examples here together. All right, so again, in number 2, we see that both equations are solved for y. They're in slope-intercept form. So we've got step 1 done for us. So we're ready to make this Indiana Jones substitution here. So 7x minus 16 can go in the place where y was, and that's equal to 2x minus 6. So let me, I'm going to put it in like pink highlighter. There was a y here. Y was equal to 2x minus 6, but we got rid of that y. In its place, we put 7x minus 16. So now we're ready to go ahead and solve this. So I'm going to go ahead and subtract 2x from both sides. I like to leave positive x's. So 5x minus 16 equals negative 6. Add 16, add 16. We get 5x equals 10. Divide by 5, divide by 5. X equals 2. Great, don't get too excited. We got to find the other value. So y equals 2 times 2 minus 6. That's from our first equation. And that would give us negative 2. We can double check with our other equation. Y equals 7 times 2 minus 16. That's 14 minus 16. That's also negative 2. So that confirms that our answer is 2, negative 2. Okay, so in the first two examples we've seen y is solved for in both equations. Well, let's check out number 4 here. In number 4, we see the first equation is in, close to standard form. There's a negative in front of x. The second equation, though, we see y is solved for. So we still actually have step 1 done for us. We still haven't had to actually solve for one of the equations for one variable. But now when we go to substitute, we're going to substitute this value, negative 4x plus 15, but it's going to kind of go into the middle of an equation. It's going to go where y is here. So here's how it's going to look. We start by writing that first equation, negative 8x minus 8. Put on the brakes. Don't write y. We're going to replace y. We were about to get to y in that equation, but now we're going to replace it with something that it's equal to. I'm going to write it just in a different color. Now, very important. This whole quantity is going in the place of one thing. We need parentheses. So that is in the place of y. Okay, and it's equal to 0 on the other side. All right, so now we have an equation, and there's one variable, and we have to solve it. So we have negative 8x. Negative 8 times negative 4x is positive 32x. And then we get minus 120 equals 0. We can combine our like terms here. So we get 24x minus 120 equals 0. Add 120, add 120. And we get 24x equals 120, of course. Divide both sides by 24. And we get x is equal to 5. All right, let's go back and check and find the other answer. So negative 8 times 5, that's our first equation, minus 8y equals 0. And we'll get negative 40 minus 8y equals 0. Add 40, add 40. Negative 8y equals 40. Divide both sides by negative 8. Y equals negative 5. Okay, great. We got negative 5. You could stop here, but to be extra certain, you can try it out in the other equation. So let's go ahead and do that. So we'll put in, where am I? Okay. We'll put in 5 into the equation, y equals negative 4x plus 15. Y equals negative 4 times 5 plus 15. So that's negative 20 plus 15 is negative 5. So that confirms that we got the same number. So don't forget to write your answer in an ordered pair, 5, negative 5. Great. All right, so let's go ahead and look at a further example. Let's jump down to number 8 on the next page here. Notice in this one, we haven't done step 1 yet. None of the variables are solved for already. So there's really 4 choices here that you have. There's an x and a y in the first equation, so that's 2, and an x and a y in the second equation, 2 more. So we can solve for any one of those variables. Now, any one of them will work, but sometimes there are easier choices than others. And in this case, the easiest choice to solve for is the y in the second equation. And the reason for that is if we look at the coefficient is positive 1. So that means we're not going to have to actually do any division to isolate y in that second equation. So I'm just going to go ahead and write this right below this. I'm going to subtract 6x from both sides of that equation, and that gives me y equals negative 6x minus 12. So we solved the second equation for y. If it helps, you might even want to label this as equation 1 and equation 2. And the reason why this is important is this new equation that we've rewritten, this is really part of equation 2. Why is that so important to remember? Well, we need to substitute this. We need to take this value, which we know is equal to y, and substitute it into the other equation. Other is important here. If you go ahead and try to substitute it back into y in this equation, you're going to get all real numbers. You're going to get a true statement every single time, but that's not necessarily what we need to have happen. We need to take, since this came from equation 2, we need to put this into equation 1. So again, it's going to look like that place where we substitute right into the middle of an equation. So I'm going to start writing that first equation. Negative 3x plus 3. That's my bad car brakes and tire squealing. Because we slammed on the brakes really quickly because we're going to replace y with a value that y is equal to. Parentheses again are important. Negative 6x minus 12. And this is equal to 6 from that first equation. Okay, we have one equation, one variable, time to solve. Negative 3x. 3 times negative 6x is negative 18x minus 36 equals 6. Okay, we combine like terms. Negative 21x minus 36 equals 6. Add 36 to both sides. And we get negative 21x equals 42. Divide both sides by negative 21. And we get x is equal to negative 2. Great, we're getting closer. So we're going to go ahead and plug this back in. Now, we could plug it back into our solved version of equation 2. It is the easiest to find y. But I still recommend going back to one of the original equations, just because if you made any goofs when you went to step 2, you'll catch them if you plug into your original equations. So we have 6 times negative 2 plus y equals negative 12. So negative 12 plus y equals negative 12. Well, that's odd, but don't be afraid. 0 is still a number. So we got 0. We could plug it into the other equation. Just for time's sake, I'll leave that exercise for you. So our answer here is negative 2 comma 0. Great. Let's just go ahead and look at one more example before we move on to some different cases here. So if we look at an example like number 12. What's different about number 12? Number 12, again, no variables are solved for already. X here, y here, x here, y here. None of them have a coefficient of 1. So I'm going to go ahead and just pick one that I think is the nicest. So I wouldn't pick y here to solve for, just because I'm going to have to divide by 2, and that's going to give me a fraction or decimal over here. I could choose to divide both by 3, and that would at least get me a nicer number. In the second equation, neither one of these is going to turn out nice numbers. So really, it doesn't matter at this point. None of them are perfectly pretty, but if it's me, I would just do a little looking ahead to say, well, if I solve for this x, I'm going to at least get less mixed numbers here, or less improper fractions. So let's go ahead and solve for that. So I'm going to rewrite the whole equation over here. Negative 3x plus 2y equals negative 21. All right, so I'm going to solve for that x. So I'm going to subtract 2y. Negative 3x equals negative 2y minus 21. And I'll divide both sides by negative 3. When you divide this side by negative 3, make sure you divide all the pieces by negative 3. X equals 2/3 y plus 7. Notice, I think this might have been the first time that we also solved for x. Even though we've solved a lot for y, solving for x is totally allowed as well. Okay, so now let's look at our second equation. So remember, this came from equation 1. So in equation 2, I see 2 And then I'm going to not write x here. I'm going to write what x is equal to. So here's our substitution. This is what x was equal to. 2/3 y plus 7. And then minus 3y equals 19. Okay, great. So we'll go ahead and distribute our 2 throughout here. So we get 4/3 y plus 14 minus 3y equals 19. Looking ahead, the best thing to do in my mind would be to combine, to get the negative 14 over here so we have less constants floating about. 4/3 y minus 3y equals 5. At this point, you have options. If you want to, you could combine these, say this is, negative 9/3 and positive 4/3 and get negative 5/3. Or maybe you would prefer to say, I just hate fractions, get them out of here. Let me multiply both sides by 3. So if I do that here, I'm going to get 4y minus 9y equals 15. So that might be the nicest thing to do. We multiply by 3 to get rid of that, and it makes all the fractions go away. All right, so we have negative 5y equals 15, and we divide by negative 5 on both sides to get that y is equal to negative 3. Great. So that's only our first variable, though. So let's go ahead and solve for our second variable. So I'm going to go into the first equation. Negative 3x plus 2 times negative 3 equals negative 21. Okay, so that's negative 3x minus 6 equals negative 21. Add 6, add 6. Negative 3x equals negative 15. Divide by negative 3, divide by negative 3, and we get x is equal to 5. So our solution is 5 comma negative 3. Terrific. All right. There are still a few other things that we should go over. Let's talk about some special cases. So let's start to solve this as we normally would. All right, so I do see that the y was solved for in the second equation. So I'm going to go ahead and plug it into the first equation for y over there. So I'm going to start writing that first equation. Negative 10x plus 2. Put on the brakes, don't write y in its place. We're going to put what y is equal to. It's equal to 5x minus 2. Okay, and that's equal to 4. So we start to solve. Negative 10x plus 10x minus 4 equals 4. Okay, combine like terms. What? Negative 10x plus 10x, that's gone altogether. So negative 4 is all that's left, equals 4. Well, that's not right. And you should probably already be thinking from our past experiences that when we get a false statement like this, that means that there is no solution. It was a little bit in disguise because one was written in standard form and the other in slope-intercept form, but if we had seen them both in slope-intercept form, we would have realized that they had the same slope because these are parallel lines. There's no solution. So the first special case is if a false statement occurs, then we have parallel lines, therefore no solution. We'll look at an example of the other type in a second, but I'm sure you've already concluded that if a true statement occurs, then we have overlapping lines, therefore we have infinitely many solutions. Infinitely many solutions. Okay, so let's go ahead. Let's try number 15 here. All right, so we're looking at number 15, and I see y solved for right here. So I'll go ahead and plug it into y in the other equation. So negative 12x plus 3. Put on the brakes. Don't write y. Write what y is equal to. oops. Yeah, equals, drifting away, 30. Okay, so we go ahead and solve negative 12x plus 12x from the distributing plus 30 equals 30. All right, those are all gone. So 30 equals 30, which is a true statement, of course. So we have infinitely many solutions. All right, and that is the basics of what we need to know to solve system equations by the substitution method.